So today we're going to do Piecewise Linear Functions, Unit 3, Lesson 3, which should be on page 9. So, functions expressed algebraically can sometimes be more complicated and involve different equations for different portions of their domains. These are known as piecewise functions. If all of the pieces are linear, they are called piecewise linear functions. So let's look at exercise 1. Consider the piecewise linear function given by the formula. Create a table of values below and graph the function. So as I look at this table here, notice that all of your x's are -3 all the way out to +4. So I'm going to kind of classify some information here. So when I look at my functions, I have two functions. The first domain sits between -3 and 0. So I only want values between -3 and 0. So on my table, the portion that's in yellow deals with equation 1. Then I look at the second equation, and the domain, let's go ahead and change this extra x to a 0. So my domain for the second one sits between 0 and +4. So I want the value 0 to 4. So when I look also at what goes on in my domain, I notice here that because it says we're equal to, I have a closed circle at that value of -3, and then it says not including 0, so I have an open circle for the next part. If I move down to the next equation, I'm including 0, so it's a dot, a closed dot, and for 4, I'm also including 4, so it's a closed dot. This portion here represents equation 2. So the portion in yellow is where I'm going to plug in -3, -2, -1, and 0 to my first equation. So let's take a look at that. So if I plug in -3 into my equation, I have -3 minus 3. -3 minus 3 gives me -6. Let's plug in the next one. If I have -2 minus 3, that gives me -5. So see if you can fill out the other two. So check and see if you got -4 and -3. Notice how I put a dotted line down the middle of 0 because 0 deals with two different equations. So let me erase this. Now let's look at 0, 1, 2, 3, and 4 for equation 2. So if I plug in 0, that means I have a half times 0 plus 4. Well, anything times 0 is going to give us 0. So I have 0 plus 4, which gives me 4. All right. What happens if we plug in 1? So we have a half times 1 plus 4. Well, a half times 1 just gives me a half, plus 4, I have to find a common denominator. Common denominator is going to be 2 for the top and bottom. So I have 1 over 2. 4 times 2 gives me 8 over 2. But when I add these two together, I get 9 over 2 as my value, which is roughly about 4.5. So let's try the next one. So if I have 2, I have a half times 2 plus 4. Put 2 over 1. 1 times 2 gives me 2. 2 times 1 gives me 2 plus 4. Well, I don't really need a common denominator here because 2 over 2 is the same as saying 1. And then plus 4 gives me the value of 5. So I'm going to pause it. You go ahead and fill in the chart. So see if that's what you got for the rest of the table. Now let's begin to graph this. So we know that with our graph here, we have a restriction for the first part, which is -3 less than or equal to x less than or equal to 0. So I'm going to go ahead and just graph this equation of x minus 3. So first I'm going to go ahead, I'll graph this in red. So my x minus 3, I'm going to count down 3 units, because that's my y-intercept. So down 1, 2, 3. I have a point there. And my slope is going to be 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. I'm going to go the opposite direction, which goes down a few. Down 1 over 1. So I have to think of my restrictions. My restrictions tell me that I have to sit between -3 and 0. So I might have to graph a little more. Down 1 over 1, down 1 over 1. So I only want my graph to sit between -3 and 0. So everything else that is not -3 and 0 that's past those, I'm going to go ahead and erase those points. I only want -3 to 0. So I might have erased a little more. All right. And then I have to look at what's being included. So I know that -3 is included, so it's okay for my -3 point to be closed. And then my value of 0 is not included. It should be an open circle. So I'm going to go ahead and erase that closed circle there. And I'm going to graph an open circle at that point. Now I can begin to connect my graph. That takes care of the first equation. The second equation I'll do in green. I'm going to do the exact same thing, plot the points. My y-intercept is +4. So let's erase that. Y-intercept is +4, so 1, 2, 3, 4. So my point is there. And then my slope is up 1 over 2, rise over 1. So up 1 over 2, up 1 over 2, up 1 over 2. And I'm going to go the opposite direction, down 1 over 2, down 1 over 2, down 1 over 2. So I think of my restriction. My restriction tells me for my domain it has to sit between 0 and 4. So I only care about the area from here, 1, 2, 3, 4, all the way out to here. So I'm going to go ahead and erase everything that doesn't apply to that. All right. So now I have to look at my open and closed circles. So at 0, we said it's closed, so it's okay to leave it closed. And at 4, it's also closed. So my graph can connect, and I just have a line right there. So this is a piecewise function. All right, so part B says, state the range of the f using interval notation. So we're using interval notation to find the domain of both graphs. So the red graph, remember our range goes from bottom to top. Our range is 1, 2, 3, 4, 5, 6. So -6, including -6 because there's a closed circle, comma, our highest point of our red graph is down 1, 2, 3. So -3, but not including -3. Union, now let's talk about the green graph. So remember, all of our graphs are closed, so that means we have a bracket and another bracket. So our lowest value is 1, 2, 3, 4, so a +4, up to +6. So this is the range for both of the graphs. One's in red, one is in green. Okay, exercise 2. Not only should we be able to graph piecewise functions when we are given their equations, but we should also be able to translate the graphs of these functions into equations. So we're basically going to do it the other way around. Exercise 2 says the function f of x is shown below. Write a piecewise linear formula for the function. Be sure to specify both the formulas and the domain intervals over which they apply. So what I'm going to do here is I'm going to number out the different lines that I see. So I see there's a line here. I'm going to call that 1. I also see there's a line here, so I'll label that 2. And another line here, and I'll label that 3. So how I'm going to set this up is I'm going to just go ahead and write f of x equals this huge bracket. I know that I have 3 lines, so that means I should have first equation, a second equation, and a third equation. And I'm just going to kind of put my lines there to recognize that there should be equations going on, and the semicolons are going to distinguish my domains. So the first one in green, I'm going to look for my domain first. So as far as the graph goes, it goes all the way to -8. And -8 has a closed circle, so I'm going to include that. So less than or equal to x, less than or equal to. I'm going to go all the way out for my domain to -2. So my green graph's domain goes from -8 to -2. Now, let's look at graph number 2. So I'll do that one in red. Well, one thing to notice here is that wherever your graph starts is going to not include that value for the second one. So my graph starts here at -2, but I'm not going to include -2 because I included it in the first equation in green. So I'm not going to include it in the second equation. So I have -2 all the way out to 1, 2, 3. So x, and I'm going to include +3 in my domain. So it's -2 between -2 and +3. Now let's move on to the the blue graph. So I'm going from +3. Remember, I included +3 in the last equation, so I'm not going to include it in this next one. So I have 3 is less than x, less than or equal to, all the way out to 1, 2, 3, 4, 5, 6. So +6. So these are my domains for the equations. Now I begin to find out what is the actual equations that I need. Okay, so for the green graph, I'm going to first look for my slope. Remember, you're putting in the form y equals mx plus b form. So I'm going to look for my slope first. So I'm going to choose a point to kind of figure out what is the rise over run. So I'm going to choose this point here in black and the other dot originally given. So I go down 3 units, so -3 over -2. So my rise over run, -3 over -2 gives me a +3 over 2x. And so if I look at this and I actually do rise over run again to try to figure out where my y-intercept is, I'm going to start from the point where it ends and go up 3 over 2. And that'll tell me that that is where my y-intercept is. So if I were to continue to graph this graph and there were no restrictions, it would cross through this point of the y-axis, which is 7. So a +7. All right. Let's look at equation 2. So equation 2 deals with this straight line. Well, we know this is a horizontal line. So my horizontal line is at the value of 1, 2, 3, 4. So that means that when y equals 4, it sits between -2 and +3. The last graph, which is in blue, again, I'm going to look for my slope. Slope is the first thing. So I'm going to take from the point that was given, and I'm going to pick the next point here in black. So I go down 2 over 1. So rise over run, -2 over 1. gives me negative 2x. Then I need to find out what is that y-intercept going to be. So I'm going to go the opposite direction. So I'll go up 1, 2 over 1, up 2 over 1. I'll go up 2 over 1, which is right about there. We estimate that to be about 10. So positive 10 is where that graph would have intersected if we kept drawing it and it had no domain restrictions. So given here is all of your equations for the function that is provided.